start with this layer. Reconciling the effects of dribbling and spots. That was intentional. Reconciling the crippling grocery prices of America and the lovable franchise of Pokemon, we, Team Tartigrade, present to you today our product, Pokemon, a way to figure out how to get the most bang for your sauce base.
For those of you who are not familiar with Pokemon, they're basically creatures with special attacks and abilities that coexist with humans. So we essentially combine our love for this multimedia franchise with video games, TV shows, and the trading card series with our love for food in this project. So our goals were to predict the cost per pound of different Pokemon meats and to create a scalable framework that can accommodate the new generations that come out every couple years. And each generation has about 100 new species. So this is particularly useful to continue enriching the world building aspect as fans by applying economic principles from the real world to this fictional context.
To discuss what makes our project truly unique, we did take a quick look at how we use data to train our model. The data we used was collated from a lot of data sets, including some of the main series games and from a lot of sub-franchises. We took a lot of data or features that mimicked real-life metric ways to measure the prices of meat. For example, we looked at the encounter tables of Pokemon Go to figure out how scarce meat would be considered. We looked at the weight of a Pokemon to figure out how much its meat would yield, etc., etc. However, we did encounter a problem along the way. Some data sets available in the first generation were no longer available in the other. And with every passing generation, new features were added and some features were removed. In order to accommodate for this, we developed a machine language model using LP architecture that could handle losing a few features or adding a few features by having neutral weights in each category. To initially train our data, we used a linear formula using weights from the scales I just mentioned, those being weights based on total to measure macronutrients and the scarcity. And as we continue forward, we use this MLP architecture to handle the rest of the 900 Pokemon. Because of this architecture, we can also expand our framework to broader varieties if necessary. For example, genetically engineered meats. In the future, we might not have equal metrics to figure out the price of those meats. Using this architecture, we could find fair prices to put them on shelves. To look at the accuracy of our methods.
So just to check the accuracy of our method, we plotted the actual price per pound that we determined with our datasets versus the price predicted by our model for the first generation of Pokemon. And as you can see, the correlation is pretty good, which basically just means that the error score for our model is fairly decent. So now we're just going to show you a live demo of our project.
So let's say I am a broke college student in the Pokemon world that is running on EBT, and I really am craving some Pikachu. I would type in some Pikachu, and it would predict the price to be $7.25 per pound, which is unfortunately out of my budget, which is only $3. So as an alternative, I can eat any of these Pokemon listed here. Thank you for